All right, welcome to the Explainer. Today we're going to tackle a big one. You've seen those huge, kind of scary headlines about air pollution, right? Well, we're going to get into the science that's actually behind them. So, you see a number like this one flash across your screen. 7 million. It's just a massive number. It's almost hard to even wrap your head around. But what does a number that huge actually mean?
Well, according to the World Health Organization, that's how many preventable deaths are caused by air pollution. And that's not a one-time thing, that's each year. It's a number so big, it's tough to really feel the human impact behind it.
But that begs the question, right? How in the world do scientists go from just a suspicion, hey, maybe dirty air is bad for us, to a statistic that is that precise and that alarming? It's really a fascinating bit of scientific detective work. So let's get into it.
Okay, so first things first. Before you can even start counting how much damage something is doing, you've got to be absolutely sure it's the actual culprit. I mean, scientists have to prove that air pollution causes disease, not just that polluted air and sick people happen to exist in the same place. That's a huge difference.
And they don't just wing it. There's a really rigorous method for this, called the Bradford Hill criteria. The best way to think about it is like a checklist, a set of rules they follow to build a totally rock-solid case and separate a real cause and effect link from just, a random coincidence.
And this checklist is super logical when you break it down. First, pretty obvious, right? You have to be exposed to the polluted air before you get sick. Then there's what's called a dose response. Basically, the more pollution you breathe, the higher your risk of getting sick should be. And it can't be a one-off finding. Scientists in different places studying different groups of people all have to see a similar connection. And here's the kicker. If you get rid of the pollution, say a factory shuts down, then the rates of disease should actually go down. Each one of these steps makes the case stronger and stronger. So by checking off all these boxes, the scientific community can say with a whole lot of confidence that they're on the right track. They move from, hey, this could be a thing, to, okay, this is definitely a thing. They build this powerful consensus that, yeah, the danger is real. It's not just a theory.
Okay, so establishing that link is one thing, but calculating its impact across millions, even billions of people, that is a whole different ballgame. So how do they actually do that?
Well, to get a handle on the sheer scale of the problem, they use something called a health impact assessment, or HIA for short. This is the tool that takes them from knowing there's a cause to figuring out that staggering 7 million number.
You can kind of think of it like a recipe. Seriously, it's got 4 key ingredients that you multiply together, and when you do that, you get that big overall health impact number.
Ingredient number 1 is the hazard. Makes sense, right? You need to know how much gunk is actually in the air. This data comes from everywhere. Monitors on the ground, satellites way up in space, even super complex computer models that map out where pollution is and where it's going.
Next up, ingredient 2, the population. I mean, a cloud of pollution over an empty desert isn't a public health crisis. You have to know who is breathing the air and where they live. That's where things like census data come in.
Ingredient number 3 is all about baseline health. See, pollution doesn't hit everyone the same way. It's especially dangerous for people who already have health problems. So scientists need to know what a population's health looks like to begin with. How many people have things like heart disease or asthma that we know pollution makes way, way worse.
And finally, the 4th ingredient is the health risk. This number comes from all those huge studies we talked about before. It's called the relative risk, and it basically tells you how much more likely you are to get sick if they're breathing polluted air compared to someone breathing clean air. It's the piece that connects the pollution to the outcome. So, you take those 4 things, the hazard, the population, their baseline health, and the health risk, you multiply them all together, and that's how you get those huge headline-making numbers. But it's more than just a scary statistic. It's an incredibly powerful tool for making change.
Yeah, this isn't just science for science's sake. This rigorous process is the bedrock for real-world policy. It's what informs things like the World Health Organization's air quality guidelines, which are basically the official targets for what we should all be aiming for when it comes to clean air.
And take a look at this. It really shows you the gap between the goal and reality. The WHO says the guideline for those tiny, nasty particles called PM 2.5 should be just 5. But in a place like Chad in 2022, the reality was almost 90. That is just a massive difference. It really puts the scale of the challenge into perspective, doesn't it?
So the next time you see one of those big headlines about air quality, you'll know what's behind it. It's not just a number they pulled out of thin air. You'll know about the meticulous science, the causality checklists, the 4-part formula,
that all comes together to generate that warning.
What's amazing is that we have the scientific tools to measure all this harm with incredible precision. The science gives us the answers. The real question is, what are we going to do with them?